are watching session number 3 of the chapter Chemical Reactions and Equations. In the previous session, I discussed about balancing chemical equations and first type of chemical reaction, that is combination reaction. In this class, we are going to discuss about the different types of chemical reactions and corrosion and the concept called rancidity. Now I am going to talk about the second type of chemical reaction, that is decomposition reaction. The second type is decomposition reaction. The previous one was the combination reaction. As the name indicates, the reactants or two simple molecules, they used to combine and you are going to get one product. That is the combination reaction. Now decomposition reaction, decomposition is nothing but splitting or breaking, you can say. So the one reactant is going to be split and you are going to get simpler products here. So one reactant undergoes decomposition or breaking, you can say, and two or more simpler products you are going to get, and that we call it as decomposition reaction. Let me discuss with some example for that. So if I consider the example of CaCO3, that is calcium carbonate, and if I take calcium carbonate in a test tube, and if I heat that, and we are going to get the colorless gas, colorless odorless gas, and if you pass that gas into lime water, the lime water turns milky, and if any gas that turns lime water into milky, and the name of the gas is carbon dioxide. So the gas released when calcium carbonate is heated is carbon dioxide. So CaCO3, when it is heated, we are going to get the calcium oxide and the CO2. So what has happened here? Calcium carbonate is one reactant, and due to action of heat, and from calcium carbonate you are going to get two simpler products. When compared to calcium carbonate, calcium oxide and carbon dioxide you are going to get. Calcium oxide we can call it as quicklime also, and the carbon dioxide is gas going to be released. So from one you are going to get two or more simpler products here, and such kind of a splitting of reactant takes place if you get two or more simpler products here, and such kind of reactions we call it as decomposition reaction. We will see some other examples for that. So now I am going to consider one compound, that is FeSO4. FeSO4 stands for ferrous sulfate or iron 2 sulfate. The color of this compound is green, and if you just heat that, and what we are going to get, the products are Fe2O3, that is ferric oxide or iron 3 oxide you can say, and one more is SO2 sulfur dioxide, and one more is SO3 sulfur trioxide we are going to get. From ferrous sulfate, after heating, ferrous sulfate has been decomposed to get ferric oxide, sulfur dioxide and sulfur trioxide. The gas released is sulfur dioxide and sulfur trioxide, and after heating the ferrous sulfate we are going to get. So from one reactant, and here we got three simple products. Therefore this reaction belongs to the decomposition reaction. And we know that one, whenever we write chemical equation, that has to be balanced. So if you consider this reaction, and in the left side I have one iron, whereas in the right hand side, that is in case of products, I have two irons. So therefore I need to write 2 here, and sulfur will become 2 and sulfur we have 2, and everything is balanced now. So this is the balanced equation what I can consider. So we will see some other examples also. PbNO3 twice. PbNO3 twice stands for lead nitrate. The valency of lead is 2 plus, therefore you are going to get PbNO3 twice. And if you heat this lead nitrate, and the products what we are going to get are, one is PbO, lead oxide, and one more is H2O, we are going to get, and one more is NO2 we are going to get here. So the products after decomposition of lead nitrate are lead oxide, and the second one is oxygen, not water actually, sorry for that, oxygen, and after that NO2 we are going to get. So if you consider lead nitrate in a test tube, okay, and after heating we are going to get brown color vapors above the test tube here. So brown color vapors is mainly due to the release of NO2. NO2, it has a characteristic color, brown fumes we are going to get, and that is mainly due to NO2, and brown color vapors we got when the lead nitrate is heated. So we need to balance this equation also, and we know that when this belongs to decomposition reaction, because from one reactant we got 3 simpler products here. So if you consider nitrogen is 2 here, whereas nitrogen is 1 here, so let me consider I am going to write 2. Then how many oxygens we are going to get in the right side? 4, 5, 6, 7 we have, and 3 into 2, 6 we have. Therefore the oxygen is not balanced, and a trial and error method I told you, and let us assume I am going to write 3 here. 3 to the 6, 7, 8, 9 we get here, and if you write 3 also it is not going to balance here. So let me consider 4, okay, and if you consider 4 and if you write 2 here, nitrogen is going to be balanced, and lead we should write 2 here. So this is how, by using trial and error method, you are supposed to balance the equations here. And remember, in this case nitrogen gas released, it has a characteristic property that brown fumes we are going to get here, and in case of the previous reaction sulfur dioxide, and it has a characteristic odor. It has a characteristic odor, unique odor you can say, whereas in case of the first reaction carbon dioxide, the colorless, odorless gas is going to be released. This is how the chemical change involved in a chemical reaction that can be identified. Okay, we will see some other examples so that will be quite good in the decomposition reaction. And now water I am going to consider. So water undergoes decomposition, and the process I am going to write here, that we call it as electrolysis. We just try to know water, when water undergoes electrolysis, and we are going to get simpler products. One is hydrogen and one more is oxygen. Okay, and for balancing this reaction, oxygen we have 2, in the reactant side we have only 1, therefore I should write 2 here, and hydrogen 2 into 4 we have, and I should write 4 here. So from water we are going to get hydrogen gas as well as oxygen gas. But this is not as easy as it seems, because water has to be electrolyzed, then we are going to get what actually the hydrogen as well as oxygen. Some other examples we will see, that is when silver chloride, that is AgCl, when it is exposed to sunlight, and we are going to get the metal that is Ag, and chlorine gas is going to be released. So for balancing I should write 2 AgCl, and here I am going to write 2 for that one. So from AgCl we got Ag and Cl2, therefore this again belongs to the decomposition reaction. One more example we will see, that is AgBr, silver bromide, and when this is exposed to light, and we are going to get lead as well as the gas releases Br2, bromine gas we used to call it as. For balancing I need to write 2 here, and I need to write 2 here. So this is how we can consider some reactions from which actually one reactant is going to be converted into 2 or more simpler products, and that kind of reactions we call it as decomposition reaction. In simple language, you just remember, if there will be a splitting of reactants or breaking of reactants, and we are going to get 2 or more simpler products, and that reaction belongs to decomposition reaction. And I have written some decomposition reaction. In some case we are supposed to heat the reactants, and in some case we are supposed to pass bright sunlight, and in some case some phenomenon like electrolysis has to be carried, because these reactions depends on the condition what we apply, and the gas is going to be released in some cases, and that is the characteristic property of the chemical reaction here. So as I told you already some experimental methods we have for the identification of these gases. Of course, these are the practical concepts here, and let me explain in general how we can consider these reactions. So the first one I am going to explain, that is the formation of carbon dioxide. So what you are supposed to do is, in chemistry lab you need to consider test tube. Okay, and inside test tube you just add the compound, that is calcium carbonate. Calcium carbonate is amorphous solid and that has to be added, and we are supposed to heat this test tube, and we are supposed to use the pair of tongues for the heating, okay, so that it will be not harmful for you. And next I am going to consider the Bunsen burner. Okay, and using Bunsen burner we are supposed to heat that. When calcium carbonate is heated, and of course there is a release of gas, I told you, and remember the characteristic property of carbon dioxide is that is colorless, that is odorless also. Then how to identify? I told you that when you pass this carbon dioxide gas into lime water, that lime water turns milky. That indicates that the gas released is carbon dioxide. This is how first reaction has to be carried out. Similarly, the second one, that is a ferrous sulfate, that is green colored crystalline solid it is. The same thing, you have to consider a test tube and add a little amount of FeSO4. And now if you heat that one, we are going to get the gases, that is nothing but sulfur dioxide and sulfur trioxide, and it has a characteristic odor. And for the next one, that is the lead nitrate, again the same procedure has to be followed. You are supposed to consider test tube and add lead nitrate and just heat that one, and in this case we are going to get the fumes, okay, and the brown colored fumes we are going to get, and that indicates the presence of nitrogen dioxide gas. Whereas in case of the electrolysis, the method is completely different. And now I will tell you how actually electrolysis has to be carried and what actually the meaning of electrolysis is. Remember, electrolysis is, if you consider one substance that is good conductor of heat and electricity in aqueous state and molten state, we call it as electrolyte. Electrolytes are nothing but the substances which conducts electricity in aqueous or molten state, we call it as electrolyte. And if you consider any one electrolyte, and after passing electric current, that electrolyte is going to break, and the cations and anions you are going to get. The cations and anions, they respectively move towards the respective electrodes, and the discharge of ions takes place, and the entire procedure what I told, that we call it as electrolysis. So now let me explain the same procedure with some simple diagrammatic representation. So what we have to do is, you need to consider a plastic container, plastic jar you can consider, okay, and at the bottom I am going to make 2 holes, and inside the first hole I am going to introduce one graphite rod. I will make a hole and I am going to introduce a graphite rod. Graphite is one of the allotropic form of carbon, as you know, and that is a good conductor of heat and electricity. Therefore, graphite electrode is to be used. And this graphite electrode, I consider it as anode, and this graphite electrode I consider it as cathode, because the positive, this anode is connected to positive terminal of a battery. Let us assume this is the battery. This is connected to positive terminal of battery, and one more graphite electrode that is connected to negative terminal of battery. Therefore, this will be anode and this will be cathode. So next what I do, I am going to take 2 test tubes filled with water, and the test tubes filled with water I am going to place over this graphite rods. And if you place over this graphite rods, and I hope you can imagine how we are going to get. So this is the beaker with water that I placed inverted, okay, and of course we are going to get the water inside this the beaker. So this is how one simple activity we can consider. So we just try to know this is nothing but water we have, and this is the battery, and this will be the anode because that is connected to positive terminal of battery, and this is the cathode, and the electrode what I introduce, and these are the graphite electrodes I can consider, and these are test tubes filled with water, test tubes I can consider. So if you consider this kind of arrangement, and if you just pass the electric current, battery we have that supplies the electric charge. If you pass the electric current, what happens? We have a water, and I told you that one, after passage of electric current, water is going to split and we are going to get cation and anion. Cation, H plus ions are the cations and O2 minus are the anions, and all the cations move towards cathode and all the anions move towards anode, opposite charges, isn't it? And during the course of time, what happens here? Oxygen gas is collected. Okay, oxygen gas is collected towards this, that is nothing but the electrode and the test tube with respect to anode, and hydrogen gas is collected with respect to the one more electrode that is connected to cathode here. So oxygen gas is collected, hydrogen gas is collected, and physically we are going to observe air bubbles which are passing through the test tube. And what happens? The gas is going to displace water and gas is collected at the top of the test tubes like this. And from this we came to know that somehow two different gases are collected, and if you just observe the kind of gas collected, and I told you that one, towards this oxygen is collected and towards this test tube what is that? Hydrogen is collected, and I said this is hydrogen and oxygen. Then how to verify that? I hope you remember, oxygen is the combustible substance, that is a supporter of combustion. So if you just consider any substance with the burning sensation and that catches fire, because oxygen is supporter of combustion, it will catch a fire. Based on that I can consider what is actually the oxygen gas is released, because that is a supporter of combustion, supporter of a burning you can say. Then how to identify the gas released here is hydrogen. If you bring the burning matchstick and here towards the hydrogen, and we are going to get a characteristic sound that we call it as pop sound. So pop sound you are going to get, and the burning candle or burning stick, if you take near the oxygen, the burning will be with a greater efficiency because oxygen is supporter of combustion. So based on these two tests I can say the gas collected here is oxygen and the gas collected here is hydrogen. One more concept, if you just measure the amount of gas collected here, the amount of collection of gas of hydrogen is greater when compared to the oxygen. Okay, and practically this is how we are going to see, but in this case of an equation also we can guess, 2 volume of water if you consider, and here you are going to get 2 volumes of hydrogen and 1 volume of oxygen. In this is in the ratio 2:1. That indicates that the amount of hydrogen gas collected will be more when compared to amount of oxygen gas. So therefore amount of hydrogen gas collected will be more when compared to oxygen here. And one more question, that is how we came to know that towards this test tube oxygen is collected, towards this test tube hydrogen is collected, and I told you that when the ionization will be O2 minus and one more will be H plus. So all the H plus ions move towards the cathode, because cathode is negative terminal, negative electrode, and all the H plus, all the O2 minus move towards the anode, because anode is the positive terminal, positive electrode. So because of that what actually the oxygen is collected and hydrogen is collected. So this is how we can experimentally decompose water. We are going to get hydrogen and oxygen. So this is how actually the decomposition takes place. But while writing, just we write that when water undergoes electrolysis we are going to get hydrogen and oxygen. Silver chloride and silver bromide. So what I do, you are supposed to consider a watch glass, and here if you just place silver chloride or silver bromide, silver chloride if you observe, and in the presence of sunlight, let us assume in the presence of sunlight, if you consider what happens here, this silver chloride what we have, and from that we are going to get a chlorine gas. Chlorine gas is released, whereas silver will be in this watch glass itself here. Similarly silver bromide if you consider, and bromine gas is going to be released. This decomposition of silver chloride and silver bromide takes place in presence of sunlight, whereas in absence of sunlight or dark, and there is no decomposition of silver chloride and silver bromide. This is how sometimes heating is required, sometimes sunlight is required, sometimes the process called electrolysis is required for splitting of a single reactant to get two or more simpler products, and that we call it as what actually the decomposition reaction. That is the second type of chemical reaction, that is decomposition reaction. Now I am going to move with the third type. The third one is displacement reaction. Displacement reaction. So we'll see now what actually the displacement reaction stands for. Let me write the reaction and later we'll perform the activity as I discussed here. So let me consider example, later I am going to define. So if you consider iron, the metal, and I am going to consider CuSO4, copper sulfate, and when you react iron with the copper sulfate, and the products what we are going to get is, one is FeSO4, iron 2 sulfate or ferrous sulfate, and one more is copper metal we are going to get here. So if you carefully observe this reaction, in this case iron what we have, iron is going to displace what actually copper, isn't it? Iron is going to displace copper, and copper we are going to get independent, and that iron is going to be reacted with the SO4 2 minus, and that we are going to get SO4, and copper we are going to get. So what happened here, one metal or one element has displaced another element from its compound to form a new compound. I repeat, one element displaces another element from its compound to form a new compound. After displacement of one element from the another element, there will be the formation of new compound. So in this reaction particularly, iron displaces copper, and we are going to new product, that is a ferrous sulfate and copper we are going to get. And that kind of reaction we call it as displacement reaction. Self-explanatory word, displacement. One is going to take over the place of other, or I can say one is going to displace the other. So one element displaces another element from its compound to form a new compound, we call it as displacement reaction. One more example we'll see. If you consider zinc, when zinc reacts with the copper sulfate CuSO4, and now imagine, so which element is going to displace the one more element from its compound, we are going to get new compound, and I hope you can guess, zinc is going to displace copper, and what we are going to get, we are going to get zinc sulfate, and one more product will be, what is that, copper we are going to get. So zinc displaces copper, from copper sulfate we are going to get zinc sulfate and copper. So the zinc is going to displace copper here. Here also one element displaces other to form a new compound. So this kind of reactions we call it as displacement reaction. So we'll see how actually the element is going to be displaced here. So now I am going to explain the first reaction with one experimental data, and we will see how actually the displacement reaction takes place. Let us assume I am going to consider a test tube, okay, and now inside the test tube I am going to consider CuSO4, copper sulfate, copper 2 sulfate actually it is, cupric sulfate is the right name, and the physical state of CuSO4 is blue colored crystalline solid. And what I am going to consider, I am going to consider aqueous solution of CuSO4. I will take little crystals of CuSO4 and I am going to dissolve in water, and we are going to get that one. Therefore that I call it as CuSO4 solution, and try to know the color of copper sulfate is blue, the color is blue. And next what I do, I will introduce a iron nail. Let us assume this is the iron nail, and what I do, the head of the iron nail I am going to lock with the thread, and I am going to place here. This is the iron nail, this is the thread. For your reference I am going to write here, this is the nail, this is the iron nail you can consider. So this is the arrangement what I am going to consider, and if you keep this arrangement, due to course of time what happens, displacement reaction takes place. And now as I told you already, iron is going to displace copper, and then the question arises, why can't copper displaces iron, isn't it? But remember, in this case, always in a displacement reaction, more reactive element displaces less reactive element. I repeat, in displacement reaction, more reactive element displaces less reactive element. And again then question arises, how we can guess the reactivity of elements? That you are going to study in some other chapter, that is metals and non-metals, and there we are going to discuss about activity series. In that case, we will see how to identify the activity of elements. But right now you remember, the more reactive element displaces the other, and when you compare iron and copper, iron is more reactive when compared to copper, therefore iron is going to displace copper. And due to course of time, what happens here? Iron, what we have, and over that we are going to get some kind of brown color. The iron is going to be converted into brown, and the color of CuSO4 solution is blue, and that starts fading. Means the dark color blue is going to be converted into light blue, we can say. So color is going to diminish, or fading of blue color takes place, and some kind of the dark brown color we are going to get over the surface of the iron, and that indicates that iron is going to displace copper, and the kind of the element or the product formed on here will be, that is FeSO4, ferrous sulfate, and ferrous sulfate is little green in color, I told you that one, and of course we are going to get somewhat green colored or somewhat brown colored substance over there. That is the FeSO4 we are going to get, and from this activity or experiment I can say the more reactive element iron is going to displace the less reactive copper. You can consider n number of reactions like that, and one more reaction I am going to consider, that is lead Pb plus CuCl2. When lead reacts with CuCl2, and what we are going to get, I hope you can guess here, lead displaces copper here, and we are going to get PbCl2, and copper we are going to get. So this is how we can consider n number of reactions like this, and which says that one element is going to displace another from its compound to form a new compound, and that we call it as displacement reaction. So we discussed combination reaction and decomposition reaction and displacement reaction. The fourth one I am going to move with, and the fourth one we call it as a double displacement reaction. Double displacement. Double displacement reaction. So what happens in case of double displacement reactions, we will see now. So for your reference, I am going to consider the two compounds. In general I am going to consider, and later we will see. Let us assume A and B is one reactant or one compound, and one more is C and D, one more reactant you are going to consider, and let us assume this is the cation, this is the anion, and C will be the cation and D will be the anion. Remember, double displacement, of course there will be the displacement of one element over the other, but double displacement, in this case the very important keyword what you should remember is there will be exchange of ions between reacting species. I repeat, there is exchange of ions in a reacting species here. So how does the reacting species is going to exchange here? So just to see, if you consider AB and CD, so A plus we have and B minus we have, and here C plus we have and D minus we have. Cation, anion of one species and cation, anion of one more reactant you can consider. So during a double displacement reaction, the cation of one reactant that is going to link with the anion of one more reactant. Similarly, the cation of one more reactant is going to link with the the anion of one more reactant, and the product what we are going to get, the product we are going to get AD, and one more is what is that, CB you are going to get. So this is how in general I can show you how does there will be exchange of ions takes place, and in any reaction if there is exchange of ions in between the reacting species, and that kind of reaction we call it as double decomposition reaction. We will see the examples of double displacement reaction. Now I am going to consider the example of sodium sulfate Na2SO4. When sodium sulfate reacts with barium chloride, that is BaCl2, and we'll see what is the product we are going to get. And the one more reactant I am going to consider, one more reaction, that is PbNO3 twice, that is lead nitrate, and one more potassium iodide Ki I am going to consider, and we'll see what are the products in this case. As I told you that in case of double displacement reaction, there will be exchange of ions. In particular, there is exchange of cations and anions in between the reacting species, and that actually happens. We are going to get the new products here. So first one, we'll see what are the products here. Of course, we can guess what would be the product. For the explanations here, in the first one, the cation will be Na plus, sodium valence is +1. The anion present is SO4, the valency of sulfate is 2-, SO4 sulfate 2-. And if you consider one more reactant, that is BaCl2, Ba2 plus, barium, the valence is 2+, and Cl we have a minus. So cation, anion we have of the two different reactants. So there will be exchange of a cation and anion. So this is how the cation and anion exchanges here. So what we are going to get? We are going to get barium sulfate. The formula will be BaSO4, Ba2 plus SO4 2 plus, it cancels, you will be getting the formula as BaSO4, barium sulfate, and one more will be Na plus and Cl minus, that we call it as a sodium chloride. This is how the exchange of ions takes place, and we are going to get the new products like this. And I hope you can guess what would be the products in the second case, and what is the anion, what is the cation for the next one, Pb plus 2, lead 2 plus, and the anion will be NO3 minus, that will be nitrate you can call it as, and potassium iodide K plus, and anion is I minus. So exchange of ions takes place here. So Pb2 plus I minus, and what would be the product here? Lead iodide, Pbi2 we are going to get, lead iodide. Okay, and one more product will be, that is KNO3, that is potassium nitrate we are going to get. And this is how we can consider the double displacement reaction, and of course we need to balance the reactions, isn't it? Whereas in case of first one, you just see we have a 2 sodium, we have only 1 here, I am supposed to write 2, and a Cl will be 2, Cl will be 2 again here. And in this case iodine we have 2 there, so I should write 2 here, and the potassium will become 2, I should write 2 KN3 here, and I hope the equation is balanced now. So this is how there will be exchange of cation and anion in the reactants, so that we are going to get the 2 new products, and that we call it as a double decomposition reaction. And how to identify whether the reaction is a double decomposition or not practically? Remember, double decomposition reaction is accompanied by precipitation. Precipitation is nothing but the formation of solid substances here. So of course you can consider the first one, that is a sodium sulfate and barium chloride, and during the formation of a reactant in the test tube we are going to get a white precipitate of a barium sulfate, white colored solid we are going to get, and precipitation reaction, solid formation reaction, arrow mark down pointing downwards. Whereas in case of lead nitrate and potassium iodide, we are going to get lead iodide, little bit the yellow colored solid we are going to get here. So usually the precipitation reaction is going to be observed in case of a double displacement reaction, and this is how we can identify the double displacement reaction also. And that is all about the fourth type of chemical reaction, double displacement reaction. Now higher version of chemical reactions we'll see, and that I call it as, we'll see the fifth one, and that we'll see redox reaction. Redox reaction. So we'll see what actually the redox reaction stands for. See, if you observe the word redox, and in the name itself we have 2 different processes or 2 different the phenomenon. We have OX, that stands for oxidation. We have RD, that stands for reduction. So 2 processes we need to remember, one is oxidation and one more is reduction, and later we'll see what actually the redox reaction stands for. So now here let me explain what is the meaning of oxidation. Oxidation, what actually the oxidation stands for. And for your reference, I am going to write the meaning of oxidation. So oxidation is nothing but addition of oxygen. Addition of oxygen to a substance, you can say. One more meaning I can say, that is the removal of hydrogen. Removal of hydrogen. Addition of oxygen or removal of hydrogen, we call it as oxidation, and opposite of oxidation is reduction. And I hope you can guess what would be the meaning of reduction. That is exactly opposite. I told you that is nothing but the removal of oxygen is called reduction, or one more sense we can say that is addition of hydrogen. Addition of hydrogen, we call it as what actually the reduction here. So this is the fundamental meaning of oxidation as well as reduction. Remember that oxidation is nothing but addition of oxygen to a substance. Reduction is nothing but removal of oxygen from a substance. That is the definition with respect to oxygen. Now we can define oxidation and reduction with respect to hydrogen also. Removal of hydrogen from a substance is called oxidation, and addition of hydrogen to a substance, we call it as a reduction here. So now we will see the example, then it will be very clear what actually the oxidation and reduction stands for. So now let me consider one example, that is copper. Copper I am going to consider, and I hope you know the color of copper is brown. And when you just keep the copper as it is for a long time, and what happens actually, oxidation takes place. Oxygen is present in the atmosphere, slow oxidation takes place due to course of time, and copper will react with the oxygen which is present in the atmosphere, and we are going to get the new compound, that will be CuO. Copper 2 oxide we are going to get, cupric oxide we are going to get, and the color of this compound will be little black, you can say. So brown color copper is going to be converted into black color cupric oxide. And when this has happened, when copper reacts with oxygen, so what happened here actually, oxygen is going to added here. Addition of oxygen takes place here, and that we call it as what actually the oxidation, and copper undergoes oxidation, and we are going to get what actually the black colored CuO. Therefore I have written that is nothing but addition of oxygen to a substance, we call it as oxygen. So in the reaction we are supposed to observe oxygen, and whether oxygen has been removed or whether oxygen has been added, and based on that we should assume whether that is oxidation or reduction. So this is the reaction, what I can say, that is the oxidation. And remember, in simple, for your reference, I am going to consider this is oxidation. Why oxidation? Because oxygen is going to be added here. So now you just remember, this process is reversible. And what is that? If I consider the black colored CuO and I want brown colored copper back, that is reversible process. So what I am going to consider, I will pass hydrogen gas over CuO. Hydrogen gas, and what happens here, when you pass hydrogen gas over CuO, of course heating is required. Okay, this is the basic criteria. Without heating you won't get such products here, because heating, that is nothing but high temperature applied, and the reactant molecules will get the high kinetic energy, so that the rate of reaction will increase. That is the basic criteria. Okay, when CuO reacts with hydrogen, and we are going to get copper, and we are going to get what actually the oxygen. And what happened in this reaction? Carefully observe. CuO we have, and in the product what we have? Cu we have here. Oxygen was here, but in the product we don't have oxygen. And what happened actually? Oxygen has been removed, and removal of oxygen, as I told you, what is removal of oxygen? Removal of oxygen, we call it as what actually? Reduction. So this is how you can consider the removal of oxygen is reduction, and addition of oxygen is oxidation. Similarly, we can explain with respect to hydrogen also. Some reactions we have where oxidation and reduction occurs simultaneously. A reaction in which oxidation and reduction occurs simultaneously, and that reaction we call it as redox reaction. Remember, where there is oxidation, there should be reduction also. We don't have any reaction, only oxidation. We don't have any reaction, only reduction. Where there is oxidation, there should be reduction also. And a reaction where oxidation and reduction takes place at a time simultaneously, we call it as a redox reaction here. So let me consider one example and how I can explain the concept of redox reaction here. I will consider the used example, that is when CuO that reacts with hydrogen, and while heating we are going to get what actually Cu and H2O we are going to get. So this is the reaction, and now I am going to tell you that this is the best example for redox reaction. And what is the meaning of that? In the reaction we have oxidation as well as reduction, and we have definition of oxygen with respect to oxygen as well as hydrogen, and you need to think over whether oxygen used definition is going to be applied or a hydrogen used definition is going to be applied here. So how to identify that one? Carefully observe, and for your reference I am going to draw such kind of lines. So now if you observe these two, CuO to Cu, we have CuO and that has been converted into Cu here. Oxygen we have in the reactant side, whereas in case of product we don't have oxygen. So what it indicates? Oxygen has been removed, isn't it? So what is the meaning of removal of oxygen? Removal of oxygen is nothing but a reduction. So this change what we are going to observe, that is a reduction. Okay, so since we have reduction and there should be oxygen also, oxidation also, what is that? Let me explain. I am going to consider hydrogen and water. If you observe hydrogen and water here, we have hydrogen, we have water. What is the main difference between these two? Oxygen we don't have here, but we have oxygen here. Oxygen has been added. Addition of oxygen, and what we call it as? That we call it as oxidation. So in this reaction we have oxidation as well as reduction. Therefore this reaction I call it as redox reaction. We'll see some other example, then it will be clear. Zinc oxide, when this reacts with coke, amorphous form of carbon C, and when it is heated, okay, and what we are going to get? We are going to get zinc and we are going to get carbon monoxide. And now we'll check whether this is oxidation or reduction or a redox reaction. We'll check over here, and you need to consider the one reactant and one product, so that what is the change we are going to observe, we'll see now. So now I am going to consider the change from zinc oxide to zinc, so ZnO to zinc, and now you imagine and try to guess what would be the answer, whether this is oxidation or reduction. So oxygen we have here, oxygen has been eliminated, removal of oxygen, and that we call it as reduction. So this change we call it as reduction. And if this is reduction, one more should be oxidation. Okay, so oxygen we don't have here and oxygen we have here. Oxygen has been added, and therefore this we call it as what actually? Oxidation. So in this reaction we have oxidation as well as reduction. Therefore this reaction I can call it as redox reaction. One more example we'll see. MnO2, manganese dioxide, when this reacts with HCl, hydrochloric acid, and what we are going to get here? The products for this reaction are, one is manganese chloride, MnCl2, and one more we are going to get water, and the gas released is chlorine gas, that is Cl2, and we need to balance the equation, isn't it? So we have 2Cl and 2Cl, totally 4 chlorine we have in the right side, therefore I need to write 4 HCl, and hydrogen we have 4, and in the product we have only 2, so therefore I need to consider 2 here. So this is how the reaction of manganese dioxide and hydrochloric acid takes place. And remember, during the reaction of manganese dioxide and hydrochloric acid, the gas released is a chlorine gas, remember that one. Chlorine gas is going to be released. And now we'll see whether this is redox reaction or not, and we'll see which one is oxidation and which one is reduction. And now I am going to draw the lines, and now you just guess whether this is oxidation or reduction. Observe what is the change. Physically it is very easy. MnO2 has been converted to MnCl2. O we have here, and oxygen we don't have here. So oxygen has been removed. What is removal of oxygen? That we call it as reduction, right? And if you consider one more, that is HCl, and I am going to consider Cl2. If you consider HCl and Cl2, what has happened? HCl and Cl2, hydrogen we have here and we don't have hydrogen. Hydrogen has been removed, isn't it? So what is the meaning of removal of hydrogen? Just recall that. Removal of hydrogen, we call it as oxidation. Therefore, this is nothing but what actually? Oxidation. So in this reaction, we have oxidation as well as reduction. Therefore, these are the examples for redox reaction here. So try to know that one. A reaction in which oxidation and reduction occurs simultaneously, we call it as redox reaction. And oxidation is nothing but addition of oxygen or removal of hydrogen. Reduction is nothing but removal of oxygen and addition of hydrogen. So this is the special type of chemical reactions. So combination reaction we studied, decomposition reaction, displacement reaction, double displacement reaction, and redox reaction. So all these are the different types of chemical reactions. So now we'll see the next concept. What I'm going to discuss is, we'll see what actually the meaning of corrosion. We'll see now what is the meaning of corrosion. So we'll see the example, then we'll analyze what would be the meaning of corrosion. So here I am going to consider one iron article, one iron material, if you just imagine, and due to course of time, and what we are going to observe? We are going to observe reddish brown color on the surface of the iron, isn't it? If you consider a nail which is hammered on the wall, and after 1 year or 2 years, if you take back the nail, and brown color has been situated over the surface of the iron, isn't it? And if you consider the old benches, old table, and we are going to observe the reddish brown color, and that we call it as rusting of iron. If you consider silver ornaments, and due to course of time, the color of a silver has been turned little bit black, isn't it? So black coating we are going to get on the surface of the silver, and silver color has been transferred into the black coated silver. If you consider copper wire, and due to course of time, over the surface of the copper wire, we are going to observe the green coating, isn't it? So green coating on the surface of the copper we are going to observe here. So these are all the examples what I said, and that is the main reason for the corrosion. That these are the examples for the corrosion. So what happened here? So silver is a metal, iron is a metal, and copper is a metal. When metals are exposed to the environment, and in the environment and in the atmosphere, we have oxygen and some kind of dilute acids if you react with that one. And what happens here? There will be a formation of undesirable compound over the surface of the metal, and that we call it as the substance has been corroded, and the process we call it as corrosion. And the examples are rusting of iron, black color coating over silver, and green color coating over copper, and these are the examples for corrosion here. Remember, the corrosion is going to take place with metals, and on the surface we are going to get undesirable product. That product is not useful for us. And remember that corrosion is not good for the metal. So corrosion or rusting of iron is a big problem these days. If iron gets corroded, or I can say if the metal due to course of time undergoes corrosion, and what happens, that will be the destruction of a metal. If you consider the construction buildings which are made up of iron, and that is going to be damaged. The ship and automobiles made up of iron, that is going to be damaged. The rails which are made up of metals, that are going to be damaged here. So iron is going to rust. That is quite a problem. Therefore, rusting of iron, in general, corrosion has to be prevented. Some prevention techniques we have. The very good prevention technique is painting is the very good technique here, isn't it? And if you coat a single layer of paint over the iron articles, that we can prevent for a little extent of time. And greasing is also one of the best method for the prevention of corrosion. And these days, instead of a pure metal, alloy are using for different commercial purpose. Alloy is nothing but the homogeneous mixture of metal with metals or metal with non-metals. We call it as alloy. Stainless steel, if you consider, that is a alloy of iron. Instead of iron, the stainless steel is going to be used because that undergoes less corrosion when compared to the pure metal, that is iron. And that we call it as what actually the corrosion and the examples and what happens when corrosion takes place for the metals. And one more concept I am going to discuss, that we call it as rancidity. So we'll see what actually the rancidity stands for. If you consider oil or fat, if you prepare food with oil or fat and after some days, if you taste that, the taste will be quite different. And if you take the smell of that odor, and that has very bad odor, isn't it? So taste changes and the odor changes here. Why? Because the food undergoes oxidation and that has been decomposed actually, and because of that the change in odor and change in taste we are going to get. And usually the fat and oils undergoes what actually the spoiling process we can say, and that we call it as rancidity of a food particles. And what happens? We have to prevent this spoilage of food. We have to prevent this oxidation of food, and what we are supposed to do is we have to add a substance, and that we call it as antioxidants. Antioxidants we call it as. We call it as antioxidants. So antioxidants are nothing but the substances which are added to food to prevent the oxidation of food, and that we call it as antioxidants here. One very familiar example I will give you. Chips package, and inside we have potato chips that is going to be fried with oil and little amount of fat we have. And if you keep that potato chips for long time in a packet itself, and after that you are going to get a bad odor, and that is going to be converted into bad product here. Therefore the chips packets are filled with a gas, that is a nitrogen gas. Nitrogen gas prevents the spoilage of potato chips. This is how some other food preservatives, antioxidants are going to be added to the food that prevents oxidation, or you can say that increases the shelf life of the food. And that is the concept about what actually the rancidity. So that is all about the concepts related to the chemical reactions and equations. In the chapter called chemical reactions and equations, we studied the physical change and chemical change, the definition and examples. What is chemical reaction actually? How we can represent chemical equation? And what is the actual meaning of balancing of chemical equation? And we learned how to balance chemical equation. 5 different types of chemical reactions we studied: combination reaction, decomposition reaction, displacement reaction, double displacement reaction, redox reactions. And we learned the concept called corrosion and rancidity. That is all about the chapter called chemical reactions and equations.